What's up guys, it's me Sir Ernest and today we're going to solve problem 8.4a of Fowles and Cassiday 7th edition. The problem reads, find the moments of inertia of each of the objects in problem 8.1 about their symmetry axis. So for letter a thin wire is bent in the form of a three-sided block shape U with each segment of equal length B. So we already solved the center mass of this object, but this time we're going to solve the moment of inertia of this object rotated about its symmetry axis. So in this case, the symmetry axis of this object would be the y-axis. So here we can treat this object to be a composite of three thin rods. Rod number 1, rod number 2, and rod number 3. And each segment has mass m. So therefore, the total moment of inertia rotated about the y-axis would be the moment of inertia of the first object rotated about the y-axis plus the moment of inertia of the second object rotated about the y-axis plus the moment of inertia of the third object rotated about the y-axis. So let's treat this one by one. So let's start with the first rod. If, for example, the axis of rotation is along the axis of this object, since there is no extension from this axis because of the fact that this is a thin rod, its moment of inertia would be 0. So therefore, its moment of inertia about its center mass parallel to the y-axis would be 0. And by parallel axis theorem, the moment of inertia would be equal to mr squared plus ICM. So because ICM, as I mentioned earlier, is 0, so this is equal to mb over 2 squared. So here the distance between the object and y is b over 2. This is now equal to 1/4 mb squared. So this is I1y. For the second one, you can see that it's the same case as number 1. So therefore, I2y would be equal to 1/4 mb squared as well. Now, since from our previous videos, we know that the moment of inertia of a thin rod rotated about the axis passing through its center perpendicular to it is given by I equals 1/12 mb squared. So this is I3y. Adding this 3, we now have 7/12 mb squared. This is the moment of inertia we are looking for. So that's it. That's the solution to problem 8.4a of Fowles and Cassiday 7th edition. I hope you learned something today. Thank you for watching and I'll see you guys in the next video. Bye-bye.